Hello, everyone. Welcome to our class on Thursday. So today we're going to get started with a warm up. It'll be a little bit about equations, but don't worry, it's multiple choice, so you can answer it with whatever one you feel like is the most suitable for this. Um, so to give you a bit of a background, back in the day, a long, long, long time ago, I was kind of a what's the word to describe it? Like a well, I mean, I was a child technically, but I was more of like a I was more like a puppy with like too much energy and not enough brain power. So once upon a time, so there's a few different anecdotes here. One time my mom was chasing me down some stairs, and then she was wearing high heels, and then I was probably like two, and as she was chasing me down the stairs, she like fell and then she broke her leg. So that was very not ideal. That's something I did when I was younger. And also when I was younger, when I was on a plane, I made my grandpa chase me around. I don't really remember this, but apparently he did. And this is bear in mind, he's like, at the time he was a grandpa. So he was chasing me around the plane here. So as you can tell, nothing has really changed since then. I haven't really grown past that. So, some things change and some things stay the same. Otherwise, what we're going to do is we're going to take a look at this problem here. So in this particular problem, so what we're gonna do is I'm gonna say, okay, so I'm on a plane here. I'm starting 2 meters away from the cockpit, where the pilots are, and then I'm running at 5 meters per second away from the cockpit towards the back of the plane. So again, I'm starting 2 meters away from the cockpit, and then I'm running at 5 meters per second away from the cockpit. So what I want you to do is I want you to pick which one of these equations do you feel like best fits the particular which equation do you feel like best fits the motion here? Right. So you want to look at equation for x. No, that's equation for my position with respect to time. And so what I want to do is I want to figure out which equation best fits my motion in this particular journey. If you are unsure, I just want you to take a guess. It's okay if you aren't unsure. If you're unsure, our goal today, so last time, if I remember when we did this, I think we hit like a 90% participation rate. That was very exciting. 90% is a lot, by the way. So our goal today, I like to set reasonable goals. Let's shoot for 80%. I like setting this 80% goal. I think it works very well. So 80%, so we have about 20 people-ish right now in class. So I think we're shooting for what, 16 people? We're at 8 people right now. Thank you all for those thank you all of those who participated so far. Let's shoot for another 8 more or so. Can we do 8 more? So our goal for today is 80% participation in our warm-up poll. I'll be very happy if we get that. So again, in this particular problem here, me, Mr. Who, I once made my grandpa chase me on a plane. In this particular problem, I started 2 meters away from the cockpit and I was running at 5 meters per second away from the cockpit towards the back of the plane. And when I want you to answer, we'll think of which equation best describes my motion. So we have 2 different choices for you so far. We want to figure out which one fits best. We have 12 people who have participated so far. Thank you for those who participated. Our goal today is we're shooting for 80% participation, which means we need about 4 more. Can we get 4 more people? We got another person, got 13. I'm very happy with that. Can we get 3 more? I'll be very happy if we can get 3 more, and then we'll move on. And then I will talk a little bit about this. We got 14. We just need 2 more people. Can we do it? Okay, if you aren't unsure, if you are unsure, just take a stab, see what you can do. It's okay. It's multiple choice. It's anonymous. Do your best here. Um, we just need 2 more. We just need 2 more people, and then we will hit our goal for today, which is 80%. Let's take another minute or so, and then we will. And then I will talk a little bit, and then we will talk more about this today. 1 more minute. Can we get somebody? Can we get some clutch answers, some clutch polls? We're at 14, 20 seconds left. All right. All right. I'll take what we can get. We did okay today. So what we are going to do is I'm going to take a look at this. So which one best describes my motion? So the one that best describes my motion is so here's what I will do actually. What I'm going to do is I'm going to show you how we might look at this problem. So in general, we can describe any motion of any object. This through the next. This is a general equation for any position of any object. The says is that our final position, position at some point is our initial position. Plus how can we move? So wherever my position is at some time is where I started plus how to move. How much do we move? Well, we move by our velocity and time. Where basically step velocity. This will give us how much to move. So this will allow us to figure out the general equation for our position. So what is our general equation here? So what I want to know is I want to know where I am. We actually don't know this. We don't know this because we want to figure out what our position is at some time. We don't actually know what our position is. What we do is we do know that my initial position is 2 meters. And then I also know that my velocity is 500 centimeters. This is our general equation. You can use this to figure out what our position is at any time. So we're going to do a little bit more of this today, but I'm glad that we got a lot of participation. We got a few more last second answers. Thank you for all of those who participated. So hopefully that we will do more of this right now. So hopefully that you are able to at least sort of get the general gist of that. Okay, so so as you can see, we've got a nice spread of answers here, but so, okay, so here is what we are going to do. We are going to move on to the next assignment of today. So after we finish the warm up, the next assignment, what we're going to do is we're going to do, it's called, it's called Wherefore Art Thou? This is a reference to, reference to Shakespearean language, mostly because it's just kind of, it's very long-winded and it's very inefficient. So this is the assignment we're going to be working on today. I will introduce it in a second, but that's the main thing we're going to work on today. It is also on Canvas, and I will let you open that in a second, but I'll introduce it in a moment. What I do want to say is, okay, so we're going to work on this today. I know that we still have to work on our last assignment, our Cohen's velocity. Some of us haven't finished it yet, but some of us have revisions. I don't want you to start that until after you finish this, just because this one I think is a little bit more conceptual, I think a little bit more important. So I want you to finish this one first, the one we're doing today, before you go back and finish it or revise it. In terms of due dates, the Cohen's velocity part 2, the one we did on Monday, that's going to be due Sunday, Monday, which is this coming weekend. And then this assignment that we're working on today is we're going to do next Thursday, Friday. But I'm hoping that we should be able to finish most of this one today. So that's sort of the plan for today. Now I'm going to introduce the assignment that we're working on. So this is an assignment that basically, okay, so here's the I'm going to introduce it real quick. So here's the introduction. So in general, if you have any sort of family or parents or guardians or whatever, they always want to know where you are at any given point in time. If you don't, I'm sure your parents or families or whatever, they're going to be like, where are you? Question mark, question mark, question mark. Because they want to know where you are at any given point in time, because they don't want, you want to make sure that you're not doing any shenanigans. However, you are a physics student, and you're very efficient, and you don't want to have to text them every time you change positions, right? Every time you go to class, or you go to your friend's house, or you go to the bathroom, right? You don't want to have to text them every single time. That's very efficient. Now, the thing is, as a physics student, here's what you decide to do, is you say, hey, I'm a physics student. I can actually give you an equation. So that equation will allow you, parents, family, to figure out where I am at any given point in time. So the idea is, okay, if you want to know what my position is, you want to know my x at some time t, all what you need to know is what my initial position is, plus how much I've moved during that time frame. So what you can say is, hey, I started here and I'm moving at this speed, and that'll allow you to figure out where I am after some given time. So this means that your position equation is just your initial position plus your velocity times time. So I've given you a general equation that you can use here. X is equal to x naught plus v times t. So again, I want to reiterate, x naught, this is a subscript 0. It's like another variable, but it means our starting position. I know this is going to be kind of hard to understand. This is the notation that's very commonly used, and it probably makes no sense here. So I just want you to treat this as it's a variable that just says where we start. And it's not x times 0. It's just our starting position. So in this equation, our x naught is our starting position, our v is our velocity, our t is our time, and then our x is the position at any given point in time. And we're going to be using this to try to figure out some equations of where we are. So another thing that I want you to consider is that you won't have every single variable given to you. Sometimes you may know some things, like for example, in a warm-up, we only knew our velocity and we knew my starting position. We did not know my time and my final position. So if you don't know anything, just leave it as the unknown, and that'll be your general equation. Your goal is to write equations for the following scenarios and try to solve the questions posed by your parents, your family, guardian. They're going to say, hey, I want to know where you are, and you're going to use your equation to tell them where you are. So your reference point for each problem is your home. I want you to be careful with directions here. I want you to treat north, south, east, west as x and y directions. Parents don't want to do an equation. Well, this is your chance to educate them. Say that, hey, you know, if you don't like physics, that's setting a bad example for me. So this is your chance to teach your parents and your family how much you love physics and how meaningful it is. So this is your chance to be an educator. So okay, so I want you to be careful with directions here. Treat north, south, east, west as your x, y directions. Right, east, west is x, and north, south is y. And I want you to be careful and use negatives and positives as well, and include compass directions when relevant. So some things that are going to be very important is I want you to tell me what my velocity is this in what direction, and my displacement is this in this direction. So make sure your directions are there, and make sure you have the proper units. So that's I will be trying to make sure that everyone sort of has that as well, because that's very important, because your parents want to know. It's important, right? If you just say, hey, I'm 100 meters, right? They don't know if you're south or north, right? You got to say I'm 100 meters south, right? So that's very important. And you got to say, I got to give them a unit too, right? If you just say I'm 100 north, are you 100 miles? Are you 100 kilometers, right? Your parents could start freaking out, or they could be like, oh, you're in the yard because you're 100 meters away. So that's very careful, right? You want to tell them exactly where you are, because they want to know exactly where they are. Otherwise, they're going to freak out. So you need to give them an exact unit and an exact direction. Very important. Okay, so that's one thing. That's sort of the gist of it. Another thing that I want you to consider is each question is completely unrelated to the previous one. So I know a lot of times in the previous assignments I haven't made this clear. It's very easy to be like, okay, for this question I'm going to use the same numbers from the previous question. That's not the case. Every single question is completely independent of the other question. I just want you to focus on the question itself and ignore anything else that you read in the past. Okay. So I meant to, okay, so the warm-up problem, in this warm-up problem here, I have a problem written, Supergirl flies through the air at 500 meters per second for 5 seconds. How far did she fly? So I'll give you about, like a minute or so to try to just, work that out while I set up the example problem on the board. So for the example problem, I'm going to do this on the board, show you exactly how to do it. And then you can sort of take notes on the assignment, follow along here, and then we'll do a practice problem before we set the main one. So take a minute just to quickly crank out that warm-up problem, and then I will go through the example problem. In this problem, no direction for this problem. This problem is just a very quick warm-up. You don't need to worry about direction here. You will have to worry about direction in a second. So for now, just treat it as just a very quick, get the system rolling, get the brain rolling, and then we will move on. Okay, so hopefully you were able to figure that out. What I'm going to do now is I'm going to start going over the example problem. So this example problem is on your assignment here, and I'm going to go over it. So our goal here for this problem is to write an equation for this problem. But to do that, I think the best way to do is let's just first start off with identifying some things that we know for this problem. So in this particular problem is I start at home and walk at 10 meters per second each. That is pretty straightforward. Okay, so the first thing, before we write an equation, it's helpful for us to identify what we're given, what we know in the problem. So what do we know in the problem? So first off, we want to know, okay, where is our starting position? Well, I've told you where we started. We're starting at home. And remember, we're using our home as a reference point. Meaning that at home, our x is 0. So because we're starting at home, that means our starting position of x naught is equal to 0. So we know what we're starting at. B, what is my velocity? Well, my velocity is 10 meters per second east. You can also just write this as positive 10 meters per second.
What was Sorry, what was the starting point?
So we're starting at home. So our starting point is just going to be 0. Can I move the camera over? Oh, am I? Hold on. There we go. Okay, sorry. That should be better. Oh yeah. Sorry. I forgot to switch the view, so now you should be able to see everything. Okay, cool. So this is better. Okay, so now we know where we're starting. We're starting at x equals 0. Okay, let me review this real quick, just so I think I realized that's okay, so where are we starting? So in this problem, we're starting at home. We're setting our home to be our reference. This is the sign which means that a reference point, what does it mean? It just means that everything at the reference point, our position is 0. Because we're starting at a reference point, our initial position, our x naught, our x is 0. So our initial position is going to be 0. What is my velocity? When the velocity, what I gave you is my velocity is 10 meters per second east. So my velocity is just 10 meters per second east. I can also write this as positive 10 meters per second. If I were to solve the compass here, right? South, east, west. This is very similar to an XY graph. This is positive. This is positive X, positive Y. This is negative. So it's very similar to that. So which is why you can just write it as a positive 10 meters per second. And now we can write a position equation. So what's our general position equation? Our general position equation is x equals x naught. So our position at any point in time is our initial position plus our velocity in the time, which is time per unit. Well, we know our initial position and we know our velocity, so we can just simplify this into x equal to 10 times. So now I know if I just know what my time is, I can figure out what my position is. And if I know what my position is, I can figure out how much time it is. This is our general equation. And with this general equation, this is very powerful. And now we can talk how to solve any problem related to this scenario. So let's give an example problem. So for an example problem, I walked for 10 seconds. And I want to know how far east I am from home. So all I have to do now is all we have to do is I can just plug in 10 seconds for our time. So our time position is our velocity 10 times the time, which is 10. And now our final answer is now we are now 100 meters away. So now when we multiply this out, we get our final position, and our final position is 100 meters east. Okay, so that's a good example problem. That's a problem we can do if we know our time. What if we know our distance? What if we know our distance instead? So if we know our distance instead, let's say for the example, we know that our distance is 500 meters east. That means we know our final distance is 500. And we know that, once again, we're going to use this general equation here. X is equal to 10 times t. So we know what 10 is. We don't know what t is. So if we solve this out, we get that t is equal to 50 seconds. So, and we can do this for any time or any distance, and we can figure out one from the other. This is a very powerful equation for position equation. Okay, does anyone have any questions about this? I think the setup here is most important is identifying what we know. These are our givens. All you do is you have the given, you just plug this into your equation, you can get your position equation. Okay. So now what we're doing is we're going to do a quick practice problem here. It's on your sheet, but I also have it on the bottom of the screen. I don't know if you can read it, but hopefully you can. Okay, so for your practice problem, what you're going to do is you're going to do something very similar to this, and I've sort of given you a bunch of stuff to solve. So in this particular problem, you start 200 meters west from home, and you run 100 meters west in 10 seconds. So what I want you to do is I want you to figure out your starting position and your ending position and your time. And then I want you to write down your position equation. And then I want you to write down your velocity. And then I want you to write down, when you are 550 meters. And then I want you to solve the last one. So for your position equation, yeah. So once you do E, when you figure out your velocity, you may want to rewrite your equation once you have your velocity. Yeah, okay. We'll see what we can do here. So I'm going to give you a few minutes to work this out, and then once you get a little bit chance to try it, I will go over it. And I'm trying to trying to explain what I mean, but I'm thinking about it. So I'll give you a few minutes to work on this by yourself, and then I'll go over it how to do this problem. So in general, in your position equation, I think one thing I forgot to mention is, in general, your position equation, you generally want to figure out what the velocity is, and you generally want to figure out what the solution is. And if you generally want to move your time as unknown, you generally want to leave your position unknown. The idea is that you want to figure out where you are and something. And we have one of our distance. You may need to figure out. So the general equation should go something like this. Yeah. Let's take another 2 minutes or so. Oh, no, 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 no. This is nothing last. I forgot to erase that part. But that's a good catch. Good catch, Billy. Good catch. Okay, so I'm gonna start going over this. Let's talk about this in a sec. Let's talk about this. Okay, so first off, where are we starting? Well, in this particular problem here, we're starting 200 meters west. So I can write 200 meters west. It might be more appropriate for this problem. Actually, write this as a negative 200 meters. So the left is negative, and right is positive. So I think it might be more appropriate to actually write with negative 200 meters. What is my ending position? Well, I start at negative 200, so 200 meters west, and then I write another 100 meters west. So I can figure out that my ending position should be negative 300. And this is because this is just negative 200 minus 200. Position is negative 300. What is my time? This occurred over 10 seconds. Okay, so I think I messed up the order here. I think I meant to put this after the velocity. So let's first figure out our velocity. So my velocity is, there are a few different ways of doing this. You can either plug this everything into this equation to get your velocity, or you can just look at how much your position changed. What I want to do is I'm just going to show you how to use this equation again. So in this particular problem here, if I say x is equal to x naught, my final position is negative 300. My initial position is negative 200. All I'm going to just plug this into screen. Plug my time here. And then plus v times t. So if we do this, again, my velocity is just negative 10 meters per second. You can also do this by just looking at how much position change. So our position change by negative 100. This is another way of doing it as well. For my general position equation, what I'm going to do is I'm trying to fill in my velocity, and I'm trying to fill in my initial position. So my position equation is something like x is equal to my initial position, which is negative 200, minus 10. So again, we want to leave our x's unknown, and we want to leave our times unknown, right? Because we want to plug stuff into that to figure out the. Whereas our velocity is always going to stay the same, and our initial position is always going to stay the same. So that's how we need these as number, how we need these as variables. So in general, the general format for your position equation is going to look something like this, where you want to know your velocity, you want to know your initial position, you want to use those methods. Okay, so now let's do F. For F, we want to figure out where we are. When we are 550 meters west, how long have we walked for? So this is where we can use our general position formula. We're going down, so x is equal to negative 300. The final distance column is negative 550. We walk 550 meters west, which is negative 550. This is equal to negative 200 minus 10. So we can write this out. Negative 350. The t is 35 seconds. It's 35 seconds to walk 550 meters west if you're starting from 300 meters west. Okay, so hopefully this gives you a good, robust place to start. In general, you're just looking to figure out this. If you can figure out your position, general equation, you can do any problem. This is what you're looking for in general. So what we're going to be doing for the rest of the day is we are going to be doing exactly that. We have a bunch of different scenarios involving your family, what the things you're doing. You're going to your friend's house, you're going to the park or whatever, and they want to know where you are. And you are going to try to tell them where you are through an equation because you love physics. So does anyone have any questions for me before I let you get started?
Do we have to do that first problem that's like Supergirl?
Yeah, but yes, but that should be a very quick algebra one.
Do you just multiply 500 by 5?
Mm-hmm.
Okay.
Just to get you on a general order. a general idea of how velocity relates to time and distance. So yeah, that's just for the first problem. The rest of the problems are going to be more along lines of this. So yeah, so you're going to be starting with question 4, and then you're going to be trying to move to question. So question 7 is a mastery problem that you can do. It's optional. Yeah, so I'm sorry. I'm going to put you into the groups in a second. Just give me a second. Okay. So you're going to try to do questions 4, 5, and 6, and then 7 will be optional. If you don't have any questions, I will put you in the groups now. And then, yeah. Okay, so it's 1:09 now, so I am going to wrap up and talk about what we are going to be, what you should have done. So here's is what your expectations are. So I want you to finish the assignment we're doing today by next Thursday, Friday. So you'll have about a week to work on it. So hopefully you were able to move through at least a few questions today, if not finish it or almost done with it today. And then the codenames velocity part 2, the one that we kept working, that we started last Friday, I believe, and we kept working on Monday. I want you to finish that by Sunday, Monday, so Sunday for us, before the start of next class. So those are the only 2 assignments that we have. Other than that, that's it. If you have office hours from 2:40 to 3:40 today. Other than that, I will see you all next Monday.
Thank you.
Thank you,
Very
Mr.
well. Bye-bye.
Thank
Thank
you.
you. Thank you.
Thank you.